Hello everyone and welcome. Today we're diving into a really cool topic, the structure of an atom. I know, it might sound a little complicated, but I promise we're going to break it all down step by step so it's super easy to understand. Ready? Let's get started. Okay, so first up, just take a look at this. Have you ever thought about how weirdly similar our huge solar system is to a teeny tiny atom? I mean, really think about it. You've got this big thing in the middle and then other stuff circling around it. It's kind of mind-blowing, right? We're definitely going to come back to this idea a little later on.
So here's our game plan for today. First, we'll cover the absolute basics. What even is an atom? Then we'll meet the little particles that make it up. After that, we'll see how electrons get organized, and we'll circle back to that whole solar system thing. And you'll want to stick around till the end because I've got a quick cheat sheet for you that's perfect for exams. All right, let's do this.
All right, section 1, the basic building block. So what in the world is an atom? The simplest way to think about it is like a Lego brick. It's the tiniest fundamental building block of, well, everything. The air, this screen, you, it's all made of atoms. They're so small you can't see them, but they're the foundation of pretty much all matter.
You know, we didn't always know about atoms. It was actually a huge scientific mystery. Think of it like a detective story. Our first detective was John Dalton. He's the guy who basically said, hey, I think these things exist. Then came Rutherford, who gave us a peek at the basic structure. And finally, Niels Bohr cracked the case of the electrons. It was this amazing puzzle that scientists solved piece by piece over many years.
Okay, now for the fun part. Let's shrink ourselves down and go inside an atom to see what it's made of. There are 3 main characters in here, 3 fundamental particles, and once you get to know them, everything else about chemistry starts to make sense. So check this out. Right in the middle, you've got this dense little ball called the nucleus. That's where you'll find the protons and neutrons hanging out together. And then, see these little guys zipping around the outside? Those are the electrons, kind of like little planets orbiting the sun. Okay guys, pay close attention here. This is super important, especially for exams. You absolutely have to know this table. It's simple, really. Protons are positive. P for proton, P for positive. Electrons are negative. And neutrons, well, they're neutral, no charge. Easy, right? And where are they? Protons and neutrons are in the nucleus, and the electrons are on the outside. So, we've met the particles, but what about those electrons? Are they just flying around all chaotic like a swarm of bees? Nope, not at all. There's actually a really neat and orderly system to how they're arranged, and that system is what gives an atom all its unique properties. Let's take a look. The best way to picture this is to think of an apartment building. The nucleus is the ground floor. The electrons can't just live anywhere they want. They have to be on specific floors. We call these floors shells. The first one is the K shell, then the L shell, then M, then N as you go up and away from the nucleus. Each floor or shell has its own energy level. Okay, so how many electrons can fit on each floor of our apartment building? Is there a rule? Yes, there is, and it's a super simple formula from our friend Niels Bohr. You've got to remember this one. 2n squared. It looks a little scary, but it's not, I promise. The n is just the shell number. So for the first shell, n is 1. For the second, n is 2. You get the idea. Let's actually use the formula now. It's easy. For the first shell, the K shell, n equals 1. So we have 2 times 1 squared, which is just 2. So the K shell can only hold a max of 2 electrons. Now for the L shell, n is 2. So 2 times 2 squared, well, 2 squared is 4 times 2 is 8. So 8 electrons in the L shell. See the pattern? The M shell can hold up to 18, and the N shell can hold a whopping 32. It's that simple. Okay, let's bring it back to where we started. Remember that picture of the solar system and the atom? Now that you know about the nucleus and electron shells, that comparison's going to click into place even better. It's pretty cool. Look at this side by side. It's so clear. In the solar system, you've got the sun in the center and planets orbiting it because of gravity, right? Well, in an atom, you've got the nucleus in the center, and electrons orbiting it because of a different force, electrostatic attraction, positives and negatives attracting. But the basic design, a center with things orbiting it, it's exactly the same idea. And get this, here's another parallel that is just wow. In both systems, almost all of the weight, the mass, is packed into the center. For the solar system, it's the sun, obviously. For the atom, it's that tiny nucleus. It's just a beautiful example of how nature seems to love reusing its best ideas, whether it's for something as big as a galaxy or as small as an atom. All right, final section. Let's do a super fast recap. This is your exam cheat sheet.
All the most important stuff you absolutely need to know, all in one place. You ready? Let's do a quick-fire round.
Okay, let's go. What are the three particles? Proton, neutron, electron. What are their charges? Positive, neutral, negative. Where are they? Protons and neutrons in the nucleus, electrons orbiting. What are the orbits called? Shells, KLMN. What's the magic formula? 2n squared. And who are the three scientists you need to know? Dalton, Rutherford, and Bohr. Boom! If you remember that, you are golden for your exam.
So we've gone from the giant solar system all the way down into the tiny world of the atom, and we've seen this incredible repeating pattern. It really makes you wonder, doesn't it? If nature uses the same blueprint for something cosmic and something atomic, where else is that pattern hiding? Maybe in our own biology? In technology? What do you think? It's a pretty amazing thought to end on.